All right, welcome to section 5.2. In section 5.2, we're going to focus on what we call balancing equations. And remember from 5.1, we talked about the conservation of mass must always be obeyed. Excuse me, the conservation of mass must always be obeyed, which means that we must have the same number of atoms on the left side or in the reactants as we do on the right side or the products. And this is called just balancing equation, making sure we have the same amount on the left as we do on the right because we have to obey the conservation of mass. And this is how we balance equations. So you look here, we have Na plus Cl2 yields NaCl. Does that look balanced to you? Well, if you go ahead and look here, you have one Na on the left, one Na on the right. You have two Cl's on the left, one Cl on the right. So what are we going to have to do? We're going to have to do something called a coefficient, which means we're going to have to put a large number out in front of the entire compound. So, like I said, we have one Na, one Na. That's good. We have one Cl here and two Cl's here, which means that I'm going to put a 2 out in front. But now what does that do? That gives me two NAs on the right and one Na on the left. So what I'm going to do is I'm going to put a 2 out in front of that as well. And this is called balancing equations. And there's kind of a step-by-step process to help you balance equations. You're going to add the coefficient, and a coefficient is what we just got done talking about, the last thing that was on the review worksheet for chapter 4. For example, we had 5 H2Os, and I had you identify how many hydrogens you had and how many oxygens you had. Now, if we hide that 5, if we take away this 5, we just have one H2O. However, if I go back and I put this 5 back up again, that 5 is a coefficient. That 5 is telling me I have 5 molecules of water. So, one thing when we're balancing equations is we'll never change the tiny numbers, and the tiny numbers are the subscripts. To review what a subscript is, we might have something like this: Al2SO4 3. You guys would know that's aluminum sulfate. We named it in the last chapter. However, these subscripts are all these numbers. We are never going to change those numbers. We're always just going to put a number out in front here. A 1, a 2, a 3. Okay, whatever you can do, you're going to put a number out in front. That's your subscript. Never going to change that. When you balance, you're going to count the number of atoms on the left-hand side of the equation, and you're going to count the number of atoms on the right-hand side of the equation. And you're going to make sure they equal. You're going to have to keep adding coefficients until you get the equal number. And when a coefficient is not there, we could just assume it's 1, just like it is in algebra. Now, one additional rule to kind of help you out when you're balancing equations, there are 2 elements you need to save until the very end. You're going to save oxygen and hydrogen until the very end. Those are going to be the last 2 elements you always balance, because those will help you out very much. So, let's do an example. We have an equation here. We have NaOH plus H2SO4 gives us Na2SO4 plus H2O. Now, let's look at how we have to balance this. Before, and the before is really on the left-hand side. Let's see how many you have without the number. You know what? I'm going to do an example on my own, guys. All right, let's do an example on our own, just so we get a hang of it. We have Na. Let's go over the one we just did. Na plus Cl2 yields NaCl. Now, I want to make sure that we got everything here. We got to make sure we have the equal amount on the left and equal amount on the right. So, on the left-hand side, how many NAs do we have? We have one Na. On the right-hand side, how many do we have? One Na. So we're good. So our Na is good. Let's go to our Cl. All right. On the left-hand side, how many Cls do we have? 2 Cls. On the right-hand side, how many Cls do we have? 1 Cl. Is that balanced? No. So how do we change that? We're going to put a 2 out in front here. Well, now I have 2 Cls and 2 Cls, so my Cls are good. Is this equation good now? Well, not quite. Let's go back and look at it. How many NAs do I have on the left-hand side? I still have that 1. But now when I put this 2 here, how many NAs do I have? I now have 2. So what other coefficient I'm going to have to add? I'm going to have to add a 2 here. So if we go through and look at, make sure that this is balanced, I have 2 NAs on the left. Here's 2 NAs. I have 2 NAs on the right. We're good. I have 2 Cls on the left, and I have 2 Cls on the right. So that is a balanced equation. So that is going to how you're balancing equations. You kind of go back and forth. You go back and forth with each other to make sure that you have the total number of total number right on each side. Now we're going to do a little more difficult one just so we can get the hang of it. Here we go. We have aluminum plus Fe3N2 yields or produces Aln plus Fe. All right. Let's go ahead and let's look at my ALs. I have 1 AL here. I have 1 AL here. All right. So far, so good. Let's go look at my irons. I have 3 irons on the left. I have 1 iron on the right. So how can I change that? I can put a 3 out in front. So now I have 3 irons. Last one, I have 2 Ns on the left. I have 1 N on the right. So I have my 2 Ns and my 1 N. So how am I going to have to change that? I'm going to put a 2 here. Now I'm going to put a 2 here. So are we good? Well, let's go through. Let's double check. In the black, I have 2 nitrogens. 2 nitrogens. That's good. I have 3 irons on the left. I have 3 irons on the right. That's good. Let's look at aluminums. I have 1 aluminum on the left. Uh-oh. I have 2 aluminums on the right. So how am I going to change that? I'm going to put a 2 here. And now I have 2 and 2. And my equation is balanced. And we could go through that one more time. 2 aluminums on the left, 2 aluminums on the right, 3 irons on the left, 3 irons on the right, and 2 nitrogens on the left, and 2 nitrogens on the right. We have a perfected, balanced equation. So that is how we work on balancing equations. We're going to work on this in class tomorrow. This is G.K. Clenard, and I'm signing off.